Hello everyone. Today we're going to be talking about expected payoffs in the planting and Palanpur game. So, we want to remind ourselves about the assurance game between Aram and Bina that we looked at previously. So here we have the payoff tables for that game. What can we see there? Well, we can see that there are two strategies, plant early and plant late, and with those two strategies, the players can end up at one of two Nash equilibria. Either early, where they get payoffs of 4-4, or late, where they get payoffs of 2 and 2. Now, when we think about this, we have a payoff dominant equilibrium. The payoff dominant equilibrium occurs when there is no other equilibrium that is Pareto superior to it. So if you recall here, when we look at this game, what we can also think about is the fact that we can compare 4-4 and 2-2. When we compare those two Nash equilibria, we can see that the Nash equilibrium where both players get 4, early, payoff dominates the Nash equilibrium where players both get 2, okay, which occurs where they have late. So early is Pareto superior to 2-2. Okay, so early with 4-4 is Pareto superior to late with 2-2. Okay, so what this means that early is the payoff dominant equilibrium. Now, when we think about this here, as a general rule, the Pareto efficient Nash equilibrium in an assurance game is payoff dominant. So what we can see here is that early is Pareto efficient because there is no alternative outcome that is Pareto superior to it. Right? There's no other outcome where players could do better without making at least one of the players worse off here. In fact, if we look at 4-4 versus 3-0, 3 and 2-2, 4-4 is Pareto superior to all of those outcomes, and there is no alternative which is Pareto superior to it. It's therefore payoff dominant and the Pareto efficient Nash equilibrium of that game. Okay, now this is all well and good, but something else we need to think about in this game is the fact that there are still two Nash equilibria. Even though one of the Nash equilibria is payoff dominant, that doesn't mean that we know what players are going to do if they actually had to play this game. So if you and me had to play this game together, and we had these same strategies and these same payoffs, there are two Nash equilibria, and we don't always know which ones we're actually going to play if we had to play the game in real life. So, when a game has multiple equilibria, like in this game, when we're thinking about Aram and Bina as we originally illustrated them in Chapter 1, we don't always know what strategy a player will play if they had to play the game. Right? So there are multiple equilibria. We can see one is payoff dominant, but we don't know if that's the actual equilibrium that's going to happen because there are multiple equilibria. So imagine you are Aram and you think Bina or other farmers who are like Bina will play early or late with different probabilities. So imagine you think that she's going to play early with probability P and she's going to play late with probability 1 minus P. Now, we're using these two because there are two strategies, right? And we know that with probabilities, what do we have here? P plus 1 minus P. What do we see there? That sums to 1. Okay, our probabilities have to sum to 100%, right? They have to sum to 1 because they're fractions. P is 0 less than or equal to P less than or equal to 1. Okay. Now, with these probabilities and with the payoffs that you have for the different outcomes, we can construct a new idea. This new idea is what we call an expected payoff. The expected payoff is the payoff to a strategy given the probabilities that the other player has for playing their different strategies. So an expected payoff combines probabilities and payoffs. So let's think about what that's going to look like. So if we're going to think about Aram's expected payoff for planting early, what do we think that would look like? Well, his expected payoff to planting early, which we're going to call pi hat is an expected payoff, an expected pi, and his expected payoff for planting early, which we're labeling there in the parentheses, is going to be equal to the probability that he thinks Bina plays plant early, multiplied by the payoff he receives when he plants early and when other people plant early. Now, we're going to contrast that with the complementary probability 1 minus P when other people plant late, and then he's going to get the payoff that he receives when he plants early versus when other people plant late. Then we're going to look at Amram's expected payoff of planting late. his expected payoff for planting late is going to be the probability that other people play plant early, which is multiplied then by his payoff when he plays plant late versus when they play plant early. And then we add that to 1 minus p times the payoff that he receives when he plants late when other people plant late. Now you might be thinking this is a little bit confusing, so let's go back to the game table where we can see what this would look like. So also intuitively, what we want to think about here is in order to get to an equilibrium or in order to get to a better outcome for the game, what a player is going to do, they're going to try to maximize their expected payoffs. So let's look at the game table and let's think about the payoffs that Aram receives. So Aram can get payoffs of 4, 0, 3, and 2. If he plants early when Bina plants early, he gets a payoff of 4. If he plants early when Bina plants late, he gets 0. If he plants late when Bina plants late, he gets 3. If he plants late when Bina plants early, late, he gets 2. Now, we're saying that Bina has a probability P for playing plant early and a probability 1 minus P for playing plant late. Okay, so now what we can do is we can multiply each payoff by the respective probability with which it's going to occur. So if he plants early and Bina is playing planting early, that occurs with probability P. So 4 times P is what he gets in that circumstance, versus what he gets when she plants late, which is occurring with probability 1 minus P. So 4P and 0, 1 minus P. Now, if he were to plant late and we're trying to calculate his expected payoff to planting late, we have to multiply 3 by P and 2 by 1 minus P. We can now think about how we would put these together to construct his expected payoffs. So let's formalize that in our game table once more and just have the numbers there printed out. 4 times P and 0 times 1 minus P, and 3 times P and 2 times 1 minus P. So what did we say we needed? We needed his expected payoff to playing plant early. And we said that was going to be equal to P times the payoff that he receives when he plants early and she plants early. That's equal to 4. And that's going to be added to the probability that she plants late multiplied by the payoff he receives in that circumstance. So this is all equal to 4P. That is his expected payoff to playing plant early. Similarly, his expected payoff to playing plant late is going to be equal to 3P, 3 the payoff that he receives, times P the probability she's going to play plant early, plus 2 times 1 minus P, the payoff he receives when she plants late and he plants late, multiplied by the probability with which she will play plant late. Now what does that all equal? That equals 3P plus 2 minus 2P, that's equal to 2 plus P. So these are our expected payoffs. These are the expected payoffs that the players Aram receives for playing plant early and plant late in this game.